Okay, yeah. This video we are going to talk about rational functions. You know that rational function is just a fraction of polynomial, monomial, or the bottom is polynomial, the top is monomial. So it's just a fraction of these polynomials. So remember we graph this function, fractional function. It rational. See, rational function. Rational function is just a fraction of the top could be number, and this is variable, or this could be x2 minus x plus whatever, you know, these are rational function. So what we did, we got to find the horizontal asymptote and vertical asymptote. Horizontal asymptote that we talk about is the degree of the numerator, and the degree of, we find the degree of the denominator, and see this is as we talked about it, the degree of numerator is less than degree of denominator, so y in the vertical, so y is equal to 0. What does that mean? It's just on the top of this x-axis, you know, at the top of the horizontal asymptote, vertical asymptote, I'm sorry, x is equal to 0, y is equal to, see, we said for vertical asymptote, we set the denominator equal to 0, and whatever it is the asymptote. X is equal to 0 means here is on the top of y axis. To find the vertical asymptote, we set the denominator to 0, and in this case x is 0, so on y axis, exactly on y axis. Let's talk about some examples. For example, talk about y is equal to 2x minus 1 x plus 1. See, in this function, if you want to find the vertical asymptote, set denominator equal to 0, means x plus 1 is equal to 0. What does that mean? And in x is going to be minus 1. Actually, it's going to be this is minus 1. What does that mean? You can have, I mean, in the domain of this function, then we are going to find out, first of all, how it look like, and then we we, you know, then we can say what is the domain. You know, you remember that in linear equation like 2x plus 1, the domain is minus infinity to plus infinity, because you know it is just a line, you know, it's a line. You can give every value to x, it's up to I don't know, minus 1 million, and you get value for y. Any number, any real number, you know, real number we're talking about it, it either is a fraction or an integer, or even rational and irrational number, you know, any a real number, not imaginary. We haven't talked about imaginary number yet. But the domain of this linear is going to be from minus infinity to plus infinity. And then we had the quadratic equation, y x2 plus x, or whatever, the degree of x is 2. So either it's going to be look like this, or like, if it depends on the sign of the sign of behind x squared. So this is going to be domain. You can give every value to this, to x, any value to x, and find y. Okay? The same thing for cubic function, something like this, for example. We can give every value. So the domain of all these polynomials is minus infinity to plus infinity. Means from any number, it starts from minus infinity to plus infinity, is going to be the x value can get. So we can give every value. But in some cases, there sometimes is not like this. In some cases, you have to exclude some number. Like for example, here is minus 1. One of the asymptote is minus 1. So any number except minus 1 is going to be, it can be the value of x. The x, whatever the domain is, the whatever the x value can get. But here you can not get minus 1, because if you put minus 1 here, 2 times minus 1, minus 1, minus 1 plus 1 is going to be 0. This is going to be minus 3 divided by 0 is going to be infinity. Or undefined. The number divided by 0 is going to be infinity. So you can't give x minus 1 to this, you know, x not equal to 1, any number can be. Okay, let's get to the point to draw this. So we said vertical asymptote is equal to, we set x plus 1 equal to 0, x is going to be minus 1, and horizontal asymptote, see, when the degree of numerator and the degree of denominator is the same, we should put the leading coefficient, divide this to 2, 1. 2, this is 1. So it's going to be 2. Vertical, horizontal asymptote is going to be 2. So here, this is 2. Okay, y is equal to, and then here x is equal to minus 1. So there are two asymptotes. What do you think? What the graph is going to be look like? If it's something like this, we have vertical asymptote here, minus 1, and then we have plus 2 here. It's going to be something like this, right? Now we are going to see what this graph look like. See, usually give two value before x and before -1, less than -1, and 2 point after -1. I mean larger than -1. So we can put y is equal to x minus 1, x plus 1. So you know you can use, show you something here. We want to start with some numbers here. -3, -2, -1, 0, 1, 2, 3. Well, find these numbers. In calculator, it's just so easy. You don't have to plug in -3 here and then get y. You know, it's interesting that in here, first we write this function, okay? We write this function. And after we write this function, you know, I told you how to write this function. So you look at the second table set. You set the table. You're going to start from -3 to, and each add 1. And then you see the table. Start from -3 to +3. Okay? So we find this value here and we write it there. -3 is equal to 3.5. -2 is going to be 5, and this -1 is giving error. If you give -1 here, it's infinity. X -1, if x is -1, it's going to be infinity. It never reach. It approaches that asymptote, vertical asymptote. So at 0 we are going to have -1, and 1 at 1 is going to be 0.5, at 2 is going to be 1, and it's going to be 1.25. So we find some numbers here. -3 is going to be 3.5. It's going to be somewhere here. Okay? And then -2 is going to be 5. It's going to be somewhere here. -1 is going to give error. 0 is going to be -1. If x is 0, this is going to be here, and then 1. X is if x is 1, it's going to be 0.5 here. X is 1, it's going to be 0.5. 0.5. 2 is going to be 1. And 3 is going to be 1.20. 1. So 2, 1, and then if we go further up, 1.25, 3, 1.25 is going to be here somewhere. And if you give, see, and let's connect this point, it's going to be like this. And if we add some point, this is going to be like this. It never approach. I mean, it doesn't never get to -1. it getting so close to it, but it's not getting. So that's the way to write it. So there are two. We have vertical asymptote here, and we have horizontal asymptote there. But sometimes we don't have that. You know, there are some. There are some functions that you can't find vertical. I mean, in some function, it depends. You know, it depends where the points are, and sometimes you don't have horizontal asymptote like 1 over x. You never had. Horizontal asymptote, and the vertical asymptote is also 0. It means on the top of each x and y axis. So that's the way to draw it. Let's find solve another example. Some examples here. We say 2x2 x2 minus 25. See, what you do, the first things you are gonna find the vertical and the horizontal asymptote. Vertical asymptote, we set this denominator to 0. X minus 25, set it to 0, and we get the answer. This is the equation. We get x minus 5 times x plus 5. So x is going to be minus 5, or x is going to be plus 5. So minus 5. Let's put 16 here. So it's closer to x minus 16, and x minus 4, x plus 4, and minus 4 plus 4. Okay. Here. That's the vertical asymptote. You find x is equal to 4, x is equal to minus 4. We write 4. So there are two vertical asymptotes in this because of the, we set the denominator to 0, and you see that any number includes in the domain any number we can give except minus 4 and plus 4. So let's draw this first and then find the domain of this. But I will tell you now, from minus infinity to minus 5, okay, let's write it here. It's not like the quadratic equation or cubic function and all this, quadratic, linear, and cubic function. You can give any x value, any value to x, but here you can't give any value to x to find the y value. You can't give minus 4 and plus 4, because it's going to get, if you get here 2x2, if you give 4, it's going to be 16, minus 16 is going to be 0. A number cannot be divided by 0. Okay, this is whatever is going to be 2 to the power of 4, 32, and then 32 is infinity. So we cannot give plus and minus 4. So the domain of this function is minus 4, but minus infinity to minus 5, and the union from 5, from minus 5 to plus 5, we can give number, any number from minus 5, not included minus 5. These are not included. This is a parenthesis, it's not bracket. And then union from 5 to plus infinity. See, we are not talking about the domain of these two. You know, it's going to be. Let's talk about we talk about vertical asymptote, not we are talking about horizontal asymptote. Horizontal asymptote is just related to degree of the numerator and degree of the denominator. And we write the coefficient of this. The leading coefficient is 2, 1 is going to be 2. So if y is equal to, we are going to have a horizontal asymptote. Y is equal to, here, y, x is equal minus 5, x is equal to 5. Okay, now we are going to draw this. The same things, you know, what we do so vertical, you write it, all this, let's clear this table here. So let's draw this. X, y. Y is equal to what? 2x2, x2 minus 16. So it's really hard. I mean, you know, you start from, like, for example, start from, because we have here, you can start from minus 5, minus 4, minus 3, minus 2. Well, that's going to be a lot of number. Minus 2, 0, then 2, 4, 5. You know, you just put it in the same thing, you do. You write the equation here. The function here is 2x2 divided by x2 minus 16. Oh, this is going to be a parenthesis here, and then at the end we have parenthesis here. So we set the tables. You see, the graph is going to be look like this. Okay, but let's find out by putting the number input and output value. See, the table set, we say start from minus 5, this is 5, and it 1, yeah, it's okay. And then with second, the table, it say if it's minus 5, we are going to be 5.5, minus 4 is going to be error, because we can't give value to minus 4. If you minus 4, it's going to be infinity. Minus 4 here, you put it, it's going to be 0. You don't want to 0 at the denominator in, in this rational function. Okay. So we get minus 2 is going to be minus 0.67. And 0 is going to be 0, 1, 0 is going to be 0, 1 is going to be, 2 is going to be minus 0.67, and 4 is going to be error, and 5 is going to be 5.55 error. see, these are so let's draw. Let's graph this. So okay, so we put here. We put x minus 5 is x minus 5 is going to be 5.5. It's going to be here. It's going to be a point here, okay? And then minus 4 is not going to, minus 2, let's continue this one here. So we should have choose a point like minus 7 here, and we find the point here. So actually, let's draw this. If x minus 2 is going to be 0.67, it's going to be somewhere here. And then when it's 2, it's going to be 0.67 here. When it's 0, it's 0. And this equation, and see, what I'm going to do, we are going to add a minus 7 here. See, okay, so minus 7 is 2.96. Almost 2.7. So minus 7 is going to be 2.7. It's going to be, this is 2, and this is 3. Is going to be, if this is 3, it's going to be somewhere here. This is 5. So the point here. So actually it's going to be if you give, see, it's going to get approaching this x is equal to minus 4, and here we have find some point here, and this is look like if we connect this and then it approaches vertical axis, and then here we say 2 is going to be more than 5. Let's give some number more than 5 because we need this number. But what it's going to be is going to be like this. It's going to be like this. So that's the way you write this one,